Good morning. My name is Dr. Kieran Johnson. I am a quantum biologist, and I'm developing a scientific model for biology based on a revision of quark charge calculations. And the reason why I'm doing this is that we have a cosmological model that can't be reconciled with an atomic model. When we use the standard atomic model framework for quark charge calculations for fermions. So here we have a comparative analysis of the two models. On the standard model on the right, where hydrogen has a proton and an electron, and deuterium has a neutron, a proton, and an electron. Tritium has two neutrons, a proton, and an electron. And helium has two protons, two neutrons, and two electrons. This is a standard model. And we're using charge calculations for the quarks based on up and down quarks, where an up quark and a proton has a charge of plus 2/3, and a down quark negative 1/3, and there are two up quarks and one down quark, and we add them together and we get an overall charge of +1. And in the neutron, in the standard model, we have a down quark negative 1/3 and an up quark of 2/3 and a down quark of negative 1/3, and we add them together in the neutron and we get an overall charge of 0. And that is a model where there are no positrons and the neutron has an overall charge of 0. Okay. In the new atomic model based on Boson statistics, the new quark charge calculations are as follows. An up quark has a charge of -1, and a down quark has a charge of +1. And we multiplied them together so that the two up quarks and one down quark in a proton has an overall charge of +1. And in the neutron, two down quarks, which are +1, multiplied them together with the up quark -1, we get an overall charge of -1. So in the atomic model for bosons, here we have a model that shows that a neutron has an overall charge of -1. So how do we reconcile the difference between the standard model and the new atomic model for bosons that I'm using in the supersymmetry inversion system? Well, we add a positron. So here we have a neutron -1 plus a positron +1 gives an overall charge of 0. So we have a same overall charge as in the standard atomic model, but we have included positrons. So here we see a neutron is -1, and we also include positrons in the model. So here we have a model of hydrogen on the top left, a proton +1 and an electron -1, overall charge equals 0. In the anti-hydrogen case, a neutron has a charge of -1, and there's a positron in the orbital layer having an overall charge of 0. In deuterium, we have a negative neutron and a positive proton, and a positron and an electron in the orbital layer, and an overall charge of 0. So deuterium has an overall charge of 0. And here we have tritium, where we have two negatively charged neutrons and one positively charged proton in the nucleus, and we have an unstable atom. And we have two positively charged positrons in the orbital layer and one negatively charged electron. So the orbital layer has an overall +1 charge, and the nucleus has an overall -1 charge. Again, in helium, we have two protons, two neutrons. So in the nucleus, you have an overall charge of 0, stable atom. And in the orbital layer, we have two positrons and two electrons, overall charge of 0. So here we have an idea that by changing quark charge calculations in the Boson statistical kind of framework of supersymmetry inversion, we can understand that the orbital layer and the nucleus can have different charges. In the case of tritium, which is an unstable atom, we end up an orbital layer having a +1 charge and a nucleus layer having a -1 charge when adding them together. So that gives an indication why tritium is an unstable atom, because it's not in a zero state. If you look at hydrogen, there is a zero state when adding the electron and the proton together. And the antihydrogen, yeah, there's a zero state when you add the neutron and the positron together. But the proton has a positive inner core and the neutron has a negative inner core. So we have a new model that we can use based on a charge calculation for the quarks and the proton and the neutron that's different from the standard model. And this really provides a way of looking at the boson statistics. So boson statistics is great when you're looking at a helium Bose-Einstein condensate. And anybody that's been kind of following my work in relation to the He-BEC isotropic singularity, I've been building that as the model for what the universe looked like before the beginning of time. And we see in helium here, the bottom left-hand corner, that helium contains the 2 protons and 2 neutrons. So the overall inner charge of 0. Whereas in the standard model, the thinking is that helium only has 2 positively charged protons in the nucleus. And so when you get an alpha particle emission and that logical thinking that is created from that model, the standard model, you get the idea that a nucleus of helium has an overall charge of +2. Whereas in the new model, in the atomic kind of model for boson statistics, the neutron and positron combination to give the zero charge means that the alpha particle emission, or the helium nucleus, has no charge. So the thinking that comes from this model is different from the thinking that arises from the standard model and alpha particle emission. So we have to really start again from a new perspective in order to understand alpha particle emission from the He-BEC isotropic singularity. And that's what I've been doing. I've been looking at this new model which really says, well, neutrons are negatively charged. Neutrons don't have a zero charge. And how can I justify that? How can I justify the fact that I think neutrons have an overall charge of -1? Well, there's a couple of things. We know that neutrons are bigger by mass than protons. So I've been taking the bigger mass to relate to the mass of the positron that's present. So when you have a neutron plus a positron giving you an overall zero charge, then you can understand, oh, the standard model that we've had has been missing positrons because neutrons are bigger. And so I've been using that as a logical framework to go, okay, if we start from this new thinking, what does that mean? Well, we know that there are 3 quarks in the proton and 3 quarks in the neutron. So 4 3s are 12. 4 times 3 is 12. So the alpha particle contains 12 quarks. And in helium, there are 4 other particles, the 2 positrons and the 2 electrons in the orbital layer of helium. And from that perspective, we have 4 on the outside traveling inward and the 12 quarks going outward per atom in this helium Bose-Einstein condensate alpha particle emission. So this is a new framework in which to consider the structure of atoms. And there are further details that I'll share in other videos, but this should give you at least a glimpse into the reason why our thinking in terms of atomic structure and the periodic table needs to be reconsidered. It needs to be reconsidered in light of the new charge parity solution that is being offered by this new model. And this new model allows us to reconcile between the cosmological model and the atomic model. And because they are able to be reconnected together, whereas the standard model of fermions and their proton-neutron calculations based on fractions and based on adding, that model cannot be reconciled between the atomic model and the cosmological model. It really makes us go, okay, one model can show us 5% of the universe based on atoms, and that's the standard atomic model based on the fractions and adding. And then we look at this other model, the one that's using positrons plus a neutron to give zero charge, and that neutron's a -1, and that is able to be reconciled with 100% of the universe. It identifies dark energy as the alpha particle emission. It identifies the dark matter as the 4 fundamental particles, right? The 2 positrons and the 2 electrons in the s orbital layer coming inward in the inward trajectory to give us the dark matter particle, the gravitational process, an inward trajectory. So when we have a model that can show us 5% of the universe, shows us a matter-based universe that's external and physical, that's the standard model. It's great for making stuff that's external and physical. But we're applying that model to human biology, and human biology is not external to you. It is you, you know. So I think that this new model is a better model to show us how biology works, how the unstable atoms are really important for human biology. And this new model really allows us to go, okay, like a solid, like a liquid, they're both made of atoms, but one has motion and the other one's kind of fixed in position. The standard model provides us the solid. The new model provides us the liquid. So it's like a phase transition. The unstable atoms are like the liquid. The solid, stable, atomic system that the standard model provides are like the solid. So we have now 2 models, a model for solids and a model for liquids. The liquid model uses unstable atoms. The solid model uses stable atoms. So we can build an understanding, a logical framework to really look to the role of unstable atoms, the isotopes, in biology to give the animate nature of being. So we can look at the solid atoms and see 5% of the universe. We can look at the new model and see 100% of the universe. We've been created through the unstable nature of atoms because it gives us the animate ability to transform one thing into another. There was no evolution available really in the standard atomic model because it didn't see the unstable. So whereas all the interesting biologically relevant processes arising in an evolutionary context through the instability of atoms through a lens of isotopes. So we must venture into the unknown, into a new model, and really explore that in terms of its functionality with respect to biological evolution. We are not stable beings. We are not stable atoms. We are the unstable nature of isotope physics and the atomic evolution. Thank you for taking the time for listening, and explore the model. It has some relevant information in terms of our evolutionary processes operating within an unstable framework that allows animate nature in biological beings. Thank you. Hi again. I hope you liked this latest video. Subscribe to get more info on the singularity physics model. And yeah, science is taking a bit of a twist and a turn at the moment. The inverted symmetry of opposites providing context for a new way of looking at atomic structure through stability of the pinhole camera, the atomic singularity. If you want to have a look at an interesting scientific exploration of the atomic singularity, check out the next video. Thanks a lot. Take care. Bye.